All right, hello everybody. As she said, my name is Daniel Hix. I am a software engineer at DigitalOcean on the storage platforms team. And this is 4 ways to spin up a Kubernetes cluster. Just a quick, who am I? As I mentioned, I work at DigitalOcean. I'm on the storage platforms team. We do a lot with Kubernetes on my team, hosting sort of an orchestration platform for our storage products. I graduated from West Texas A&M, go Buffs. I'm also a current computer science student at Georgia Tech for my master's. And I also really enjoy open source, contributing back. Some of my first projects were contributing back to the .NET runtime, as well as like GitHub Desktop and the external secrets operator for Kubernetes. So, jumping right in. Often, companies, we measure things, sort of your Kubernetes maturity, per se, in terms of a day one versus day two operations. Where day one is sort of you're getting your feet wet, booting up a cluster, deploying applications into it, testing things out, seeing what works, possibly automating some of that. And the more mature model would be day two, where you have sort of things like automatic logging, monitoring, ingress and egress, as well as sort of backups, hardened security, things of this nature. And so we're going to focus more on getting from day one to day two, since the process of getting from day one to day two can not only be days, as in the name, but it can also take weeks, months, or sometimes even years to get there. So we're going to talk about how to sort of speed your way or accelerate how to get there. And we're going to do that by using things like a managed Kubernetes service, as well as picking up the best technique for your process to spin up your clusters. So this is what we're going to cover today. The 4 different ways. We're going to go over first the web interface. Most clouds have a web interface, so we're going to specifically use DigitalOcean's Kubernetes interface. We're also going to use a command line to do so, to boot up a cluster, as well as look at things like Terraform and Pulumi to boot up a cluster. And my disclaimer is everything here will be focused on DigitalOcean's Kubernetes platform, because it's the one I have access to. I will say, though, that every method that we're using today or demoing today is also available for any other cloud platform. AWS, Azure, Google Cloud all have their own web interface and CLIs, and they also all have their own providers for Terraform and Pulumi that are openly available. So this applies for anything, not just what we're showing today. So first off, let's do the web interface. And because I am a wimp, I recorded my demos, because you never know what can go on with live demos. And that's awesome. Speaking of. All right, so. We're going to keep this small. This is just doing the UI via the web interface. You can see this is just going through and picking the various options on DigitalOcean. Slightly hard to see, but it's since it's smaller. But you can do things like choose your own cluster size, how many nodes, how big do you want the nodes to be. There's several other options, such as region, or if you want the high availability control plane. And so this is sort of a very quick way to do it, a very visual. You don't need to be super technical to do so. If you're working on a proof of concept, it's very simple to do. And it's just a real quick way to get into it. And then from the rest of this, this is just showing it booting up, as well as how to get connected. So normally you would download something like the kubeconfig file or something that you would put on your machine that allows you access into the cluster, as well as most cloud providers will allow some form of UI to interact with the cluster. On this one, it specifically shows just using the regular default shipped Kubernetes dashboard. that would get if you, say, booted up Kubernetes on your home machine or something of that nature, which is what we provide at DigitalOcean. And then here's the dashboard that we provide from that. And this is just showing the various pods that are inside the cluster. Nothing too crazy or new. We'll see if we can get the slideshow to work. All right. So the pros and cons of this sort of way of doing things. Like I mentioned, it's very fast to get started. You can boot it up right away. It's just a couple clicks of a button, nothing too fancy. It's very visual for people who like learning visually. I myself really like graphical interfaces, but that's just how I roll, how I learn, how I do things best. Might not be great for you, but like I said, it's very easy to spin up and down. A huge downside of this is it's hard to share this among various people. How I click the buttons or the options I choose, you only know about that from me. I can tell you how I did it, and you can try to do it the same, but you might get something different. You might end up with a different configuration. And in that sense, it's very hard to repeat the same thing over and over again. Also, clicking through the buttons, it takes time. So it's very hard to do over and over again, as well as like the configuration for it. Like I say, it's stuck in my head. If I go on vacation, you have no idea what I did. So there's no way to get it, and so it's just sort of stuck with the creator. It's best for prototyping something very quickly. If I just need a cluster to show you something cool, or to add something, or just to check the install of, say, I want to check out a new operator or something of that nature, 100% perfectly fine for that. It's also good for comparing the different cloud providers. Say I want to know what does AWS's interface look like versus Google Cloud, or DigitalOcean versus Azure. It's very good for that, and you can sort of see what fits your needs the best. And it's also okay if you're willing to accept the technical debt that comes with not being able to store that configuration is something you're going to automate later, or something that you're okay with up front. And so next, we're going to go over the command line. Most cloud providers provide some form of command line to interact with their services. We are no different. We provide a tool called the DOCTL tool, or DOCuddle tool, or however you choose to pronounce that word. So here you can see I'm just loading up interacting with our Kubernetes service. I'm saying I want to create a cluster called my awesome CLI cluster, minus some screen jittering. And then I want a count of 3 nodes. And so this does take a little bit, but through the magic power of editing, we'll see that this is going to speed up fairly fast. And we're going to jet right to the end. And then the DOCTL tool will also do some extra fun settings where it will actually download the kubeconfig onto your machine and change your current context for kubectl to your cluster that you just created. This is usually beneficial just for getting quick access to things, but then we can just run kubectl and you can see that we have pods in all of our namespaces and things of that nature. So the pros and cons of this, very similar to a UI. It's fast and easy. It's also really developer friendly. For those that like working with the terminal, this is the way to go. It's also slightly possible to automate it. You know, bash scripts are a thing, and you can very easily put this in just a file that somebody can run and boot. The inputs. The downside, it's still slightly difficult to share configuration. While it is an automated script, there is no state per se of what is actually up and running. Say if you have developers booting this up every time they enter into development mode, there could be 10 clusters running. The command line doesn't know this. You can run, the cloud provider might provide a way to list all the clusters, or they might not, depends. As well as if you're going between cloud providers or switching contexts fairly often, their CLI tools are going to be vastly different from each other. They all have different interfaces. They all provide different services. Everybody calls them differently. It's just, it won't be very consistent from provider to provider. AWS or Google Cloud all do different things than how any other cloud provider does things, and so on and so forth. Since they have very similar pros, they're best for very similar things, such as quick prototyping, proof of concepts, understanding the cloud provider's API. So you saw where with doctl we did Kubernetes. All of those command line arguments are almost identical to our REST API that we provide behind the scenes, which is literally all this is calling. So if you need to get familiar with a cloud provider's API, CLI tools are usually a very good way of doing this. And as I mentioned, it's also very good for writing very basic automation. Spin up a real quick cluster by running a bash script, et cetera, et cetera. And so next, we're going to view a slightly more automated, consistent way of doing things. Very nice. The first two were sort of a day one more operation, where we're going to be focusing more on day two for the next two. Yeah.
All right, let's figure this out. It really hasn't. It's when your computer's working real hard. Let's find out. All right, do not move.
Ah.
Stand up there the whole time. It's this. You want to try a different dongle? Yeah, let's do that.
I'm also going to fire up my machine. Please hold tight. All right. Oh, yeah, you're welcome. Quick poll. Who pronounces it cube cuddle? Who pronounces it kubectl? Wow. Clear preference here.
Anybody else want
Any other pronunciations? Cube control, right? Why did I not think of that? Anything else? Cube cussle. Oh, yeah, well, because sometimes you just have to cuss at your computers. That is very... That is super reasonable. Let's see. All right. Why did the robot cross the road? Because it was programmed by the chicken. I learned that from my 10-year-old. How are we doing over there? Do we want a different computer? Last time it was a computer. All right. Well, we had some issues with like a 2015 earlier. I don't.
All right.
Anyway, thank you all for your patience.
All right. And see, I tried to record the demos just so I could avoid technical difficulties. Go figure. All right, so as I was saying, the first two, the web interface and the command line, they were focused more on day one sort of model of maturity in terms of Kubernetes. So the next two, Terraform and Pulumi, they're going to be focused more on sort of the accelerating to day two / day two maturity model of booting up Kubernetes clusters. So this video, well, if it's too small, I can't really do much. So first off, we're just going to cat some files, look at them. This is just showing the sort of the provider Terraform file that you would do for a DigitalOcean provider in Terraform. It just mostly says what the provider is and the version that we're going to be using. The next one is going to be, I believe, the actual Kubernetes cluster that we have defined in Terraform. So you can see I'm defining a resource, which is a Kubernetes cluster that I call my cool cluster. I'm putting it in the region SFO3, as well as declaring its name. This is the name that shows up in the UI, as well as a node pool specifying specific sizes, as well as how many I'd like. And then this is just sort of showing, for this method, you do need a DigitalOcean API token, which is the same thing as what you would need with the CLI. But I've already done it, so we're not going to worry about that. Usually first, you have to run Terraform init, so there's some initial steps. This goes and downloads the provider, anything else that you might need that Terraform can configure for you. And then right from there, we run for Terraform plan. The nice thing with Terraform is it actually shows you what it's going to do, shows you what it's going to create, the things that the state that it's going to collect, as well as it'll tell you things that it's going to find out after it creates the resource. So this will make an API call to DigitalOcean to create a cluster and return any state that it might need, such as like the private networking ID and things of that nature. And so we'll run Terraform apply. It'll ask us if this is what we truly want, and then we'll of course say yes. Again, through the power of editing, we're going to fast forward through this, since provisioning a Kubernetes cluster sometimes takes 3 to 10 minutes, depending on the options you chose, the size of it, et cetera, et cetera. So you can see us speeding through it, but this is going and getting the state behind the scenes, waiting for it to be ready, and as well as just finishing it up. So we'll skip the last couple of seconds. So once it finishes, it'll tell you that it's created a resource, and then we can just run the doctl command that we did earlier and save the kubeconfig down to our local machine and merge it with our kubeconfig that's local on our computer. And then just very quickly, kubectl to show I'm not fibbing. We do have a cluster up and running. We're just going to get all the pods inside all the namespaces. Here you can see a bunch of pods. We install Cilium by default, as well as just some DO agents that we put to monitor the cluster. So the pros and cons with this method. One of the cool pros that I think is that you can preview your infrastructure. You can put fairly complex logic in here. So sometimes what you're booting up might not always be super obvious. Running Terraform plan, you can see everything that you're going to boot up. The initial state that it's going to be that Terraform can know at that time. This also introduces the concept as infrastructure as code. Your infrastructure is no longer something that sits inside the cloud only. You can check these files in as well as the state to source control. You can also store the state out in something like S3 or DigitalOcean Spaces if you so like DigitalOcean products. As well as it's very repeatable and auditable. So there are plenty of tools out there that can audit Terraform, as well as monitor how much you spend in the cloud based on your Terraform state and things of that nature. So you can get fairly diverse with Terraform and monitoring things of how you go. The downside, this does require slightly more effort than just writing in a simple command into the command line. And you also have to have somewhat technical knowledge of the cloud provider that you're using. You could see that I specified specifically the slug for the size of machine that I wanted for my node pool. You have to know these things about your cloud provider if you're going to do that. It might not always be obvious that I need to create a node pool with a Kubernetes cluster, because if you're doing it via the UI, it automatically does it for you, as well as the same with the command line tool. So you have to have somewhat knowledge, you have to dig through the docs slightly more, and you have to go do things like go and find their provider and hope that there's good documentation on it. But this is usually best for clusters that are used by multiple people, so teams of people. This is very good because you can share the state among them. So they can all share if they go to boot up a Kubernetes cluster or say change something. Terraform, if you're using a shared state, will tell them, hey, I don't need to change anything, this already exists. If they need to say scale up the cluster, Terraform can tell them, hey, this is what I need to change from what exists to scale up your cluster. These are really good for environments such as like your entire staging environment or your entire production environment. As you can, like I say, get fairly complex with Terraform and also chain different resources together and feed them into each other. So you can build sort of a very complex setup. And it's also very good for disaster recovery. So say if I have an entire region go down, it's fairly trivial to, say, change one or two variables and boot up an entire another region in any cloud that you can think of, as most of all of them have providers and can do that fairly quickly. So last, one of my favorites, Pulumi. We're going to start with a code snippet because this is the meat and bones of this. Pulumi is very much like Terraform and can actually piggyback off of Terraform as well. If there exists a Terraform provider for it, Pulumi can piggyback on it. Pulumi is more of a library for whatever coding language you would like, whether that be Python, Java, C#, Rust, Golang in this instance. You can define your infrastructure as actual code. This right here is literally just a method where I'm defining a new Kubernetes cluster the exact same way that I did in Terraform with the exact same options. With some extra fun Go syntax with the if equals nil. If you've ever coded in Go, you know exactly what that looks like. So, running a real quick video. You're going to notice that this looks very, very similar to Terraform. It is the same thing as just run up. The difference being that they store a stack, and so I will actually pause it super fast to cover that. You can do things like define different stacks, so you can have, like, say, different environments. Your staging environment could be a stack, production environment could be a stack. This is very similar to a Terraform state. This is the state of the environment and where it's at. You can store these locally or inside of Pulumi or whatever kind of backing storage Pulumi supports. So it does something very similar to Terraform, where it also tells you this is what I'm going to create. Are you sure you would like to do this? You can go down and view the details. This is very similar to just Terraform's plan. So this shows you sort of what my code would go and do. And then you can just say, yes, I would like to perform this update. And then this is super sped through again, but this is just going through and doing the exact same thing, calling the API, requesting to create this resource, and then spitting out that we're done. We also have things where we can do outputs with kubeconfigs. In order to keep that code snippet small, we're not doing anything with the output for now. But you could realistically say, take the output and go put it in something like, say, Vault, like HashiCorp Vault, or something of that nature to share among other developers. And so, I don't know if you've ever typed in front of somebody, but it always seems to get 10 times more difficult. Recording demos, oddly enough, have the exact same effort. So you can see me struggling very hard to type in the command here. But So this is just the same thing again. We're going to go get the kube config for my cluster, just to show you I'm not fibbing. We actually went and created a cluster. Pulumi does add a small identifier to the end of your resources, so you can see I had to go grab that and come back. And then we'll just do the same thing that we've kept doing. We're just going to run kubectl, get all pods and all namespaces. And lo and behold, we're running a cluster that has only been alive for 2 minutes. So what is this good for? This is infrastructure as code supercharged. It is quite literally just code. Terraform uses the HashiCorp language, which is looks like a derivative of JSON. While it does have logic, the logic has to be pretty basic. So it's not something that you can boot something up if you need complex logic for looping or like say include and exclude this. You also get all of the benefits of the language you chose. As it goes, coding languages are very strong in being able to do very complex logic, whatever you can tell it to do. Pulumi takes advantage of this, and you can do very complex things, and they provide a mocking and integration test library for you. So you can write things like unit tests and integration tests against your own infrastructure. So like say I want to make sure that if I provide this CLI interface, and I say I want 5 nodes, you can write a unit test that says when I do that, it will give me back a cluster of 5 nodes. This helps provide sort of confidence in your infrastructure or your infrastructure as code, and sort of gives developers more confidence that what they're doing is actually it's doing what they want it to. The downsides, though, this is fairly complex. More than usual requires an engineer, someone with technical prowess in whatever language you've chose, to do what you need to do with the infrastructure. This is no longer, I need someone to just go in the UI. This is, you need in-depth knowledge of how this library works to go and use it. So this is usually best for teams of software developers that are booting up clusters for whatever they're doing it for. And when you need something that's testable. So if you need to test your code, you need high confidence, and that is a requirement for you. This is very good for that. And one of my main strong points that I like the most, if you have a certain language that your code base is in, you no longer need the context switch between it and HashiCorp language. You can make it be the exact same language that your main code base is in. The perfect example is my example was in Go. Most everything we write at DigitalOcean is in Go. So I no longer have to swap between the two, and it can live side by side. And it's fairly good for complex infrastructure. A good example is we were doing something that required a cross-region deployment to multiple regions, and they all had to tie back together. It also involves serverless functions. So this combined with serverless functions proved to be fairly complex in Terraform, to where it was taking multiple days for this small little tool that is going to be used a couple of times to boot up. We instead switched to Pulumi and could define the complex language, replace things with variables, and got it up and running in like 2 hours. So when you have something very complex, sometimes this makes it a lot easier, rather than messing with a language that's not really meant for that sort of complex setup. So in summary, we went over these 4 ways to boot up your Kubernetes cluster. The first 2, the web interface and command line. Very fast, simple, quick way to boot up clusters, sort of focused on that day 1 model of maturity for Kubernetes clusters, and the Terraform and Pulumi, sort of the day 2, we want to automate stuff and go fast type of setup. And so this just sort of shows we're focusing on making that the weeks, months, and years, we want to make that a lot shorter and make it go faster. And I'd like to say thank you for coming to the talk. Thank you for DigitalOcean for sponsoring me to come. On most everything, my name is a dusty old muffin. Fun story where that came from. But you can find me on GitHub and Twitter on that. And as also, if you want to, you can find me on LinkedIn as well.
If you would be so kind, we have time for a few questions. I'm going to come around with the mic. This time I'm going to hold it, though.
Hey, I think you said the Terraform one of its pros was it's auditable. But then Pulumi is not auditable, or is it also auditable? I mean, like in the sense of external
Yeah.
and security audit.
Yeah, so the question was, is Pulumi auditable just like Terraform? In the sense of, I believe that you can write tools to sort of audit it. The main reason I mentioned that Terraform is auditable is because I know that there are specifically plugins for Terraform, that is their sole purpose of auditing sort of your infrastructure and make sure that it's hardened in terms of a security sense.
So you could include that in the Pulumi?
Yes, more than likely.
Okay.
Yes.
She works at Pulumi, so she can.
I promise I did not slip him some cash to put Pulumi in the presentation. I had zero idea. I promise. Questions? Comments? Actually, yes.
I joined a little late, so I don't know if you mentioned this, but will any of the tools set up the control plane of Kubernetes?
Sorry?
The control plane of Kubernetes. Is it going to, like, on any of the tools that you presented, any of them are going to set up the control plane, or just spin up a bunch of hosts inside your Kubernetes cluster?
I got you. These were all focused on sort of booting something up in sort of a cloud provider. I did talk really early that every tool I mentioned or every way I mentioned has a way in various cloud providers to do it in a very similar way. Most cloud providers will boot up a control plane for you, but usually will not give you access to the control plane and instead will give you access to the worker nodes. DigitalOcean does it very similar where we boot up control planes for you. And like we give you options for highly available HA control planes, but we give you the worker nodes, and that's what, like, in our model, that's what we charge you for, is the worker nodes.
Awesome. I see a question in the back.
Could you quickly put up the references slide again?
Yeah, sure.
Thank you.
And 100%, if you want this slide deck or any of the references that I have on this page, feel free to contact me as well. I'll be more than happy to send you the slides. The references are Kubernetes on DigitalOcean. That's just just links to our product page, as well as the DOCTL docs, Terraform Pulumi docs, as well as the Kubernetes starter kit that I believe is provided by the CNCF.
All right.
I don't remember the name of it now, but wasn't there a project in Kubernetes to have like a cluster API or something where you could, do you know what I'm talking about?
Yes.
What happened to that? Is that still happening?
So, are you talking about Crossplane? No. Okay. I believe there are multiple tools. There was another one, which was called Crossplane. They provide something very similar where you can boot up resources as Kubernetes resources, and it will spin them up in the various clouds as you needed. It's very similar. Too many technical issues coming into this talk since I was last minute sort of prepping for this. So I went with Pulumi instead, but there are other ways as well.
So as far as I remember, Cluster API was a subproject of the Kubernetes project. So I would go start there.
Yeah. Could you briefly talk about the difference between the state and Terraform and the state, how Pulumi handles the state real quickly?
Sure, and I think she can probably might be able to cover more in depth on the state in Pulumi. The Terraform state is generally more, usually what I would describe as just a JSON file. And it stores sort of the state of like what is, everything that you see with Terraform plan is exactly what's going to be in that state file. You can just specify different things in Terraform to spit it out to like say S3 to where it can be shared, or you can do it locally. And I don't know if it's best practice to check it in a source control, but you can check it in a source control. Pulumi does things in sort of stacks, and so the stacks is just a very similar concept. They just sort of expose it via their tool a lot better, as well as they will natively send it to their SaaS product. I do things
Yeah,
locally instead.
that's pretty much the wrap up. I mean, the Pulumi state is a big JSON file.
Keep state locally totally?
Mm-hmm.
Or does it have to go to backend? Like Terraform, you can keep the state
Yeah.
wherever you want to, but in Pulumi, do you have to keep the state with guys?
The question was, in Pulumi, can you keep the state locally? And I would have to get back to you on that because I
I'll
work
say
there,
yes.
so I get a free account.
I can actually answer that and say, yes, you can. That's what I did for this demo. Yeah.
Excellent.
I didn't feel like pushing it, so you can configure it to just push locally. No problem.
So I see people are bringing in chairs and drinks and all this sort of thing. So I will thank Daniel once more. Thank you so much. Thanks everyone for being here. What an awesome, awesome day, and I hope to see everyone at Upscale. All right. Have a great conference. See you around.